you can all write your roll numbers on the chat board so that it will be marked you had attended the class. So as far as last class, we discussed different type of operating systems that we discussed from the part of your point, and we came to know that what exactly a type of a batch operating system, what exactly a type of your other possible ways to finding the executions. So if you go for or if you remember, we discussed different possible types, and those different possible types are not other than the part of your batch operating systems, multi-programming systems. But before to that, I discussed with you regarding the different broad classifications of operating system. So is the PPT visible to you all?
Yes, sir, visible.
Yes, thank you. So here, as far as the interactive and non-interactive, we know if a user is allowed to go for the part of your systems to work, as well as they can modify the programs during execution, then only it is an interactive one. If they are not allowed, then we can possibly say there is a non-interactive one. And in between this interactive and non-interactive, we discussed about what is a serial execution, what is a batch processing execution, how a batch is going to be framed, and instead of a process, the processor will have an experience that he has to execute a batch where similar kind of multiple tasks are together. So we can possibly go for a different part of executions, but they has to be framed into a single batch because of their necessity, because of their requirements to the resources, because of their execution type. So we can look into the similarities in between different processes, and we can able to batch them together at one place. Now coming to the next, we can go for the multi-programming operating system. So in multi-programming operating system, what we definitely believe to go for the interaction, which we do not able to do in case of batch. So we can say the problem we have, or the drawback we have in case of batch operating system, that we recover in case of your multi-programming system. But the multi-programming system also have challenges. So if you go for a multi-programming system, as far as our discussion yesterday, I told you that in multi-programming system, if I can go for the processor to check, or if I go for the processor to experience the execution, a CPU will go for one process to execution at this particular point of time. And then we can think of at this point, we can find whether we can find out other possible ways to go. That means if you want to go from one task to other task, then at that particular point, I can possibly say we will go for this P1 to execute for the current time. And if you want to switch over, multi-programming fails. If you want to switch over at this particular point, I told that every process goes for the CPU execution and IO executions. Now if they go for the IO executions, now the problem starts. The problem starts means here the CPU is no more busy for the IO executions. So CPU must need to go for the next program to execute. But when does this IO come? I do not know. So I cannot guarantee you here that whether P2 will be executed or not in multi-programming environment, or we can say in a multiple or in a multiple number of programming environment, we have this experience. Now, according to reach out the problem, or according to the solution, whatever I want to go for. Okay, let's take. I have to think of that. If a process is there and process execution is going on, I have to interrupt that process, and that interrupt will allow the CPU to switch over to the next, and the current one will go for the IO executions. So that's why here we have to look into the architecture or architectural changes into the system. So we have to do some architectural changes so that this can be possible. So what we can have in the architecture, we can have in the architecture that in some around 1940s, when we do not have storage devices, supposed to be like this. You have an input device, you have a output device, and this input device and output device, if you look into, they are directly connected to the CPU. So here they are directly connected to the CPU for any part of reading main requirement, any part of writing, we have to use this CPU. That means what I'm trying to say, a CPU is used for computation. A CPU is used for computation as well as CPU is used for reading data from the input device, writing the data to the output device. But now the question is that, have you purchased your processor to read the data and write the data to your input device and output device in a requirement time or in a need of time? No. So if you are going to use this CPU for this purpose, then definitely the the usability of the CPU is going to be compromised, and the throughput and the high utilization point that we discussed, the high utilization point that we discussed, we cannot able to go for the proof, or we cannot able to justify whether we can able to make use of this high utilization of the CPU or not. So definitely the processor utilization is degrading at this particular point. Now if you want to maintain that, then the complete architecture needs to change. So what may be the change? So in the architecture we follow a change. That change supposed to say here, in comparison to the part of your IOs, here we have input, here we have output. But in this place, if you go for the input and output has not connected to the part of your CPU. So what we are going to introduce, we are going to introduce the part of your disk. So here we are going to introduce the disk, and now it is the job of the disk to read the data from the input device and to write the data to the output device. So what I need a storage space, or we can say this is a disk, means this is my memory. And what I will require, I will require a memory controller, or we can say if it wants to read the data from the input device or write the data to the output device, I would rather say I will require a input, output, and a memory controller. So normally during the IO event, when it wants to read the data, so it wants to read the data, when it wants to go for write the data, so we will require a controller. And what that controller does, this controller does a job in between the input devices and the memory. So anything in that they can work, and that's supposed to called as the part of your DMA. So this is normally called as memory access. You are accessing to the memory during reading and writing, but you are doing this directly without using. Why it is directly? Because now you see the CPU is free from that work. CPU is no more used for reading purpose and writing purpose. So if CPU is not used for the reading and writing purpose, what they do, then definitely CPU does only what? CPU does only computation. CPU does only the computation. So if CPU does only computation, here the efficiency of your processor is increasing, and the throughput is also maximizing, and the utilization is better. And at any point of time the CPU needs any data, it will not go for the input device, because if you look into that input device speed and a output device speed, if you look into that, speed is very less. And to whom it compared to be less? So in comparison to the CPU, which starts with a megahertz or gigahertz power. So a minimum I can say 10 to the power 6 is the minimum demand, 1 million instruction that per second it will go for MIPS design. So what we say, MIPS, 1 million instructions per second. So minimum unit. So if it is go for that necessity, then input and output devices, we do not have that much speed to correlate with the need of processor. So the speed of the input device is very slow, and the processor is very fast. So we cannot able to give adequate amount of data to the processor for the execution. So to bridge the gap, what I did now, I had allowed the memory device, and this memory device can able to give the direct access to the processor. So processor can do what? Processor can directly interact to this disk. And any point of time, the processor needs the data. Processor will not go to the input device. Processor will go to the disk, which will be much faster. And with day and requirement, with day and time, this disk has created a very nice memory hierarchy to understand the logic. And what memory hierarchy we created? So disk will be your secondary storage device, then we have primary storage device. So here many more added. So we can go for the part of your RAM. Then again we had added to make it much faster. So we are going to get cache. So many revisions has been done, and this architecture is going to be revised and revised. What is the reason behind? The reason behind is that each time whatever we are experiencing, that processor is faster always. If the processor is faster always, then definitely I must supply the data to it. That means to say, if a runner running speed is increasing, then you have to increase the length of the track. If you are not increasing, then definitely the runner will complete the track, and you will be not having any process to execute. So processor speed is increasing, and if you are not increasing the space to store the data, and not only the space, but also the space with respect to what we can say, the space with respect to the part of your access speed. Space be available hoga, with respect to the access speed also increases, so that we can able to bridge the gap of speed a CPU demands with respect to different storage devices. So this supposed to be one of the best change in the architecture we brought, and make the system to work in a better environment in comparison to the traditional Hubbard 1 machine, Hubbard 2 machine. So those are to not having any kind of disk. If you follow also, floppy disk also be one of the storage devices, but appearing as floppy disk also be so late. So we can think of the first disk whatever we are using, that is also having a part of your maximum of if I remember, it is 4.4 MB. That means only 4 floppy drives. Capacity is so less, and now your disk is available minimum with terabytes. So demands are increasing, necessity is increasing, and we know a necessity is the mother of invention, and we can go for a different part of your executions from point to point of time. So this particular invention is supposed to be called as spooling. So in change of architecture language or a technical language, we call this as simultaneous peripheral operation on line. So this is called as spooling, uh, and this spooling supposed to be the one of the best asked question or frequently asked question. So we can go for simultaneous peripheral operation, or we can say spooling, spooling. So both are same, simultaneous peripheral operation online or spooling, where we say that simultaneous executions can be done because of the CPU is not depending on the input device to retrieve the data. It is depending on the part of your disk device to retrieve. So once this change appears, what we can do, we can think of the situation to go for a context switching. So DMA will do the IO, CPU will be free, and we can make the processor allotted to the next process so that we can do the execution. So a DMA takes the requirement of the IO executions, and this can be possible by means of a flag. That flag is called as high impedance flag. So in case of your flag bit contains 0, this means everything has to be done by the CPU. Once it revert to 1, that means processor saying to the DMA, do the IO, I will do the computation. So uh, here a process comes for the DMA to do its input and memory device execution, but when there is a computation, it will go for the processor. This is what we have in case of the spooling. Spooling is a very frequently asked question. Now the demand of requirement, how a process can go for the next instruction execution, and when does it come, that can be possible. And how it is possible? It can be possible by going for the part of your next scheduling, next type of operating system. So next type of operating system is supposed to be the part of your TSS. So T for time. So time share. So it's called as a time share operating system. And which time it is going to be share? It is going to share the time of the processor. That means, sorry, processor with respect to the CPU, we can say. So this is going to do the sharing of time of your processor. And sharing of time, if you could go for in this point, we can divide the time of the processor for each process. What is a basic system? I can say the basic system is that allow the CPU, what it works for, allow the CPU to execute, to allow the CPU to execute for a minimum period of time, for a minimum amount of time. So this minimum amount of time is going to be called as time slice. In many books also this is called as quantum time. In many books it is also called as the quantum time. So time slice means I have a timeline, I will slice down that with equal partitions. There should not be any unequal partition. It should be equal partitions, but still there is a exception in the equal partition. What I could say, I can give you example here, that if I say that a process, let's take have a 10 unit of time to execute. Process will go for 10 unit of time to execute, and I have a time slice of 3 unit. Now you tell me how many time slice I will take. Definitely you can say, sir, 10 by 3, so I will go for 3 unit of time. If I will go for 3 unit of time, still also I am attending only 9 unit of time. So some task of P left out or not. So the some task of P is left out, that time is 1 unit. So here the time slice is 3. So if I go for correcting my account and I will make it 4, so what will happen? So if my time slice becomes 4, it goes for what? It goes for 12 minutes of time. So if it is 12 unit of time, now also you see 10, you have execution time, and 12 is the allotted time. If I go for, then what will happen? I can say for 2 unit of time, your CPU is ideal or not. So making a system to again, and the CPU is ideal, it cannot be accepted. So here we have the exception. Exception says what? Don't make the time slice to fixed. So here I can say it is not fixed. So if somebody say whether it is fixed or not, I would say no, it is not fixed. So what is this? This can be a range of time. Now, I will understand what is a range of time. A range of time means if time slice is 3, I can have a range of 1, acceptable range of 1, 2, and 3. I cannot accept 4. And here, when the P process left with 1 unit of time, my time slice for that process not be equal to 3. It now come down to 1, depending on the process left out with the execution time. Understood to all?
Yes, sir.
Yes, sir. Yes. So each time the efficiency I am increasing. I am not going for 2 unit of time, which was completely ideal. Now, if it is not, then my system is much better. Ideal time is decreasing. The throughput definitely increase, and CPU utilization will be much better. So time sharing system is the best approach out of all the necessary inventions we have. But here we can say why so. I can possibly say if I am having n number of processes, if I am having n number of processes, at least in time sharing system, I can say when the last process will start execution. How I can say? Let us go for an example. So I can say that here when does the last process will come. So at this particular point, if you are going for that, I would like to say, let's take have such a kind of queue, and in this queue there are many processes. Let's take P1, let's take Pn. So it is the head of the queue, and this is the tail of the queue. So head of the queue, I will take the process always from the head of the queue. And here if it is the case, then processor does what? Processor will come here. So it will execute P1, and I will say processor comes with a time slice of of 5 unit of time. So can I not able to say that at what point of time this Pn will execute? Let's take n equal to 10. N equal to, if I'll take n equal to 10. So this becomes what? This becomes P10. Now, if it becomes P10, you tell me when does the P10 process will start its execution? Who can say?
P1, P1 plus P10 by 2.
No, 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 no. My question is that here I have to go for the P1 execution. So P1 execution will start at 0, and it will take one time slice of time. So it will go up to 5. If I'll have P2, then it will continue for 10 unit of time. Then P3, it will go for 15. With a assumption that every process, whatever I am going to execute, their execution time is more than 5 unit of time. Is it clear? So all processes. So let's take summation. That one starts with. Let's take P. P starts with zero. Okay, one. P1 execution time starts for with
40.
only 5, and it can go for any value greater than 5. Any value greater than 5. So if this is the case, now you see at what time this P10 is going to start its execution. आप बता पाओगे कि नहीं? So
40.
this, yes. So here I can say, let's take P4, P6, P7, now P8, now P9. So you see, so 5, 10, 15, now you 20, 25, 30, now 35, now go for 40, now 40. Now you tell me here, at 0 unit of time, when I'm executing P1, I can predict. When this, I cannot predict. I can say here P10 will come for the execution at 45 unit of time. Yes or no? Now this says that if I'm having n number of processes, if I'm having n number of processes, the last process available at the queue definitely get executed. That will not be in starvation. The last process will not start to get the CPU. That is the main intention. Because in the previous case, when I discussed about multi-programming environment, in the multi-programming environment, what I told that, yes, I know I will go for the next process, but when do I go? I do not know. When do I go is an indefinite period. But here and now I can say, when do I go to my P10 process? Being on P1 execution. Being on P1 execution. So this environment is much better in comparison to my previous execution. Yes or no? So in this case, I can say no process will be left out. No process will be left out from getting the processor. If no process will left out from getting the process, then this system never suffers with, never ever suffers with starvation. Understood? So question
Yes,
number,
sir.
So what is this process called?
will you please repeat the question?
Yeah, what exactly the process is called? Like when all the processing or execution has
It,
been all
it,
done,
it,
right?
it definitely a user process meant to say you had written a program for adding two numbers. That's I'm talking about a process. So whenever you go for execution of a process, what you do, you go for GCC plus file name dot c. So what you are creating a binary file. Yes or no? So you are creating a binary executable file. So this binary executable file you are creating where? In dot slash a dot out. So in dot slash a dot out, this is about the Ubuntu platform I'm telling. So if you are going to create the dot slash a dot out, in that dot slash a dot out, what is there? That is binary executable. This binary executable file is called as your process. And the program you had written, addition of two numbers, जहाँ पे आप लिखते हो has include stdio.h, that particular program is supposed to called as user program. And the executable binary file, whatever you are creating, that's called as the part of your process, and that comes for the execution. A program or the source code never ever comes for execution. Is it clear?
Yes, sir.
Yes, sir.
Yes. So here the situation is much more better in comparison to a multi-programming environment. So your time sharing system is one of the best system to arrange a multi-programming system, or we can say time sharing system is a superset where you can have all multi-programming systems. So if I say a multi-programming system is coming with a time sharing system, that means with a time slice, it's called as a time sharing system. So that's why in every book, almost all book, if you read, you will find a simple statement that says a time sharing system or multitasking system. Multitasking system. A time sharing system always a logical extension. So it's called as a logical. It's supposed to go for a logical extension. And what this logical extension? This logical extension is not other than the time slice we are using. And if you add time slice to every multi-programming system, every multi-programming system will work as a time sharing system. So there is no much difference in between them. But if you are looking into the performance of both, there is a significant difference. Every multi-programming system suffers with starvation, whereas every time sharing system does not look like so. So they are not suffering with starvation. So this is what we have, a frequently asked question which supposed to be answer, give a difference in between or justify the difference in between multi-programming environment and time sharing environment. How do they suffer from the part of your what? How do they suffer in the part of your executions to find out starvations? So whether starvation will be there in multi-programming system or not, justify your answer. So this kind of questions can be asked there. Now, these are possible core classifications in multi-programming, or we can say the part of your operating systems, where time sharing, multi-programming, all are coming under interactive operating systems. But if you go for next, there are many names also left out, which supposed to be called as a part of your network operating system, distributed operating system, a real-time operating system. So these are service providers. These are different kind of service providers. They must use a time sharing system, and to get the network services, we can take care of the service of the network operating system. So in a network operating system, if somebody asks what exactly we are trying to do, we know network means here systems are connected to each other in a network, and the operating system does what? Operating system will just give a flavor. Operating system is going to just give a flavor that how this interaction can be possible over a network. Here also we have multiple number of computers, and remember, in network operating system we have multiple number of computers which work together under pool. So here we supposed to be say that multiple number of computers connected with each other, it's supposed to be called as a network operating systems. So these multiple network operating systems can possibly go for Windows platform, can possibly go for the open sources also. It's not like that they will go for only one. So both the way you can go for, starting from Windows Millennium, all are supporting the part of your network operating systems, or we can say the part of your network services. Then we can go for the part of your further in Ubuntu. So Ubuntu also it is available, we can make use of. So this is about the service provider of network operating system. Now coming to the implementation, if somebody say that what kind of networks nowadays you are using. Okay, I would like to give you some examples here. In the network operating system, let us take the example of a ATM. What kind of network system you are using in a network, uh, in a ATM system? Any idea? Anybody have any idea? What are the different types in network systems? So normally we are going to make use of two different possible ways. First one is that if your software is available on the client end, if you are having the software on the client end,
Hierarchical,
yes, hierarchical.
hierarchical network system.
Okay. So, but if you look into the implementation in the real time system, we normally believe that a network system can be divided or broadly classified depending on where the particular service software runs. दैट मीन्स आप कौन सा सर्विस देना चाहते हो. दैट्स वाई मैंने स्पेसिफिकली आपको बोला कि आई नीड टू गो फॉर द एटीएम सिस्टम्स. If I need to go for the ATM systems, then in that case we have to answer whether only the EXE is running on the client, that means on the ATM, yeah, in the ATM room, whatever the machine is established, that machine is only running the exe, or the complete software is available there. Now, if you look into that, we normally say in network operating systems, normally we are using the two types of servers, and that makes a difference. That makes a difference. Why? Because if you go for the part of your server to be like in a particular part where I remember all kind of transactions. So all kind of transaction, can you believe in a ATM in a one day how many transactions are going on? So all these particular transactions, if you want to remember, then the server should be called as a part of your what uh, we can say any server which can support, they can possibly go for the part of your service to remember every transaction they can remember. So they can possibly remember each to every client to remember the part of your services. And one can say, no, I don't want to remember this. So server can possibly go for stateful, server can go for stateless. So network systems, whenever I'm going to design, so I can possibly design through a client server model only. And in this client server model, what type of server you are using, it is a stateful, or we can say it's supposed to go for the part of your stateless. Now, stateful remembers everything. So what I need a very big space on this particular client. So this could not be a remote system. So this has to be a part of your full complete system where I can establish a very big distributed database. So we can possibly go for the part of your stateless also. So stateless will be less costly, and that normally used in case of banks. I do not remember because remembering the ATMs which will be remotely located can be corrupted by the third party. So that's why we do not remember any of this particular requirement. And sometimes you say, how can we get the mini statement? Yes, you can remember, because there is a time frame. Every transaction can be remembered for 30 minutes, or every transaction can be remembered for 4 hours, 5 hours, depending on the stateful server you are using. So nowadays those kind of pictures are there, and network operating system is going to work for them. Now, if you go further, deeper, if you want to go further or deeper into the part of your design of the system, उसमें क्या design है? So then I have to look into the distributed operating system. Distributed operating system will look into the functionality, whereas network operating system is going to give the service. As I already told, that these particular operating systems are normally providing the services. So distributed operating system lookout is completely different. And in this case, the complete different lookout will say whether you are working on a centralized system, whether you want to working on a distributed system. Centralized system, whenever I'm trying to say, you can manage, or you can able to remember that a centralized system can be a client server model. And here the centralized system, why I am saying, because I have a processing element, we have a processing element, can able to process, who can possibly go for the process. And at this particular point of time, these processing elements are connected with small storage space, very small storage space I have. And this particular hello, yes, anything you're asking? Okay, so this particular part of your different processing elements, if you have, they are only given with a very small space that's supposed to be called as cache or buffers. So here we can identify that these systems are connected to the buffers, and these buffer systems are supposed to be in different situations, and depending on the situation I can possibly go for the buffers to check, and depending on their space they can identify their results. So this may be used for storing the exe file. This may be used to store some few amount of data for the execution. That's, and then they all are connected to a common IO bus. This is your common data bus, or we can say IO bus. So this common requirement is connected for all the processing elements, and then after we have the control. So here we have the CPU, that's your control unit. We rather say control unit rather than tell the CPU, because processing element is here and this will be your control unit. So control unit normally controls all processing elements. So in Flynn's classification, we have this model. This model is called as what? One single control unit working with multiple processing elements. What is that? So this can possibly go for the Flynn's classification, where I can identify a multiple number of systems will work with one single control unit, that is SIMD. So here we can have our main memory. Now you see this single main memory will give all data to the processing element, and the control unit will decide to give which data to whom. And if this is so, at this particular point of time I have to look into that every data depends on this single main memory, and that's why we have a server concept here. And every system is depending on this particular main memory. That means data normally used from single main memory. That's why it is called as uniform memory access. So in this case we have the uniform memory access, and in this possible action, uniform memory access possibly finding the process execution at this particular point of time. So now looking into the part of your other end, that means this is centralized system, which normally called as a tightly coupled system also, because of this single control unit. This is also called as tightly coupled system. Now if you want to make it more and more better, now if you want to look into the system to make it more better and better, what I do, I can possibly make everything to be individual. That means that should not be any dependency with processing element to the control unit. So what should I do here? I can make the changes. So we have processing element. We can go for processing element. We can go for processing element, and this processing element will be connected to their individual cache. So this system is much more better but costly. Then I can have main memory. Then I can go for main memory. So this system now connected to a network. So this will be connected to a network. So here we have a distributed main memory, distributed cache, distributed control unit again. So I have one control unit. So this is a CPU. We can rather say a processing element. I would like to correct this. We have CPU. Yes. So this I can go for a modification. So instead of going for any kind of particular processing element, I can possibly get the part of your executions with respect to the CPUs. So these are all whatever we are using. They are the part of your CPU, 1, 2, 3, and so on. So we can go for next. So many number of CPUs are now working. So in a distributed operating system, we can say here multiple number of computers now working at one time. So this can be in the part of your distributed operating system. Sometimes this is called as the part of your multiprocessor system also. So multiprocessor system in some case, as it is accessing a different number of main memory, this is also called as what? This is also called as non-uniform memory access. So non-uniform memory access also be called as, because of different memories we are working with. So this is what I can possibly say for the part of your different operations. So this is the part of your requirement in case of your distributed operating system. So last one, we will come to the part of your real-time system. So if you are coming to the part of your real-time systems here, in this case, real-time system is also be a case that we have hard real-time. There is a classification also. So we have hard real-time, we have soft real-time. But before going to the part of your classification, I can possibly say here real time is what? Real time means rigidity over the time. So what kind of particular time consideration I will take? So the time consideration, whatever I am possibly taking at this particular point of time, here I can possibly say the sequence of execution. I can possibly say every time whenever I am going for the real time system, they will talk you about the time. So whether the time is followed or not, whether the time is strictly followed or not, whether the time is flexibly followed or not. So this kind of particular situations are there. Now if you go for the part of your system with respect to the part of your hard real time and soft real times, we can possibly say the hard real time and soft real times will work together with respect to the part of your real time systems. Now in case of the hard real time, what we can say, in case of hard real time, the system must follow the time boundaries. If the system does not follow, or if it fails to follow the particular hard real time, then I can say at this particular point of time, the result is not of any use, and the system will be failed. System will be completely failed. Why I am saying this is supposed to be used in medical use. This must be used in arms and ammunitions. This can be used for design of braking systems. So where there is a risk, where there is a risk of life, so I can say I am designing a disc brake. The brake should take 0.004 seconds to make the bike to stop at any speed of up to 0 to 100, up to 100 we can say. So 100 speed, whatever the speed, up to 100 speed if you are going, then it will take only uh, 4 microseconds to make the bike to stop. So it may be the best practice we can go for. And if you are giving this for the microsecond time, remember, before to that, the person who rides the bike, he or she should not face the accident. So life risk is there. If you are giving if you are using, let's take what, insulin pump. If you are using insulin pump, if you are giving if you are not able to know what is the proper amount of insulin to provide to the diabetes patient, then it might be a case the patient will die. Giving more amount or less amount, if you are giving less amount, it will not work. If you are giving less amount, then definitely it will not work. If you are giving more amount, the patient will die. So that kind of possibilities are there in case of hard real time. If you're coming to soft real time, there is no that much of a system is much flexible. So there is no rigidity over the time as he had real time. So there is no rigidity over the time. That means we can check for washing machine. So washing machine have um, uh, different auto wash systems. You can choose one, you put your clothes, then you check whether they are cleaned properly or not. If it is not clean, you can increase 5 times more, or we can say 5 minutes more. It will do that. If you are baking a cake on your microwave, you check whether it is baked properly or not. If not, you can go for 5 minutes more. So that there is no that much rigidity, and this says that if the system is not able to follow the timeline, there is no failure of the system. There is no failure of the system. But in the first one, the system completely failed. The system completely failed. And this can be a possible way of going for hard real time and soft real time. Now, in between that, if somebody wants to go for a real time system, there is also from real time. So this middle one will say, if you are giving the result, but the result is not coming within the time, result is not coming within the time, that does not means the system is completely not of any use. The result is not of any use, that is okay, but system exists. The system will exist. If you are crossing the time limit, then definitely that particular result will not be in of any use. In the soft real time, we can use the out product, but in firm real time, here you cannot make use of the out product if it crosses the time. But the system will not fail. System will be as it is. So these are different possible types of real time systems we can have, and this makes a conclusion that what variety of different operating systems we can go for. So this is all about different types of operating systems. To conclude with this module, we can go for the part of your different structures to look into. So what kind of different operating system structures we have? Now, if you are looking into the operating system structures, every operating system must have a structure. Why say? Because in the execution of the first situation, when we discussed about uh, this point, the structure says that there must be one layer where only the user is accessible, and there must be another layer where only the kernel is accessible. So here they must be divided into layer to layer so that we can work better. Now, if you look into the different possible structures, I have two examples here. This is the first example, which will take you towards the disk operating system, uh, where you can see the first layer is supposed to be the users application program layer. Then comes to the system programs who allow the user to interact with the applications. And after that, the kernel mode, or we can say device driver, will come. So this part is the operating system. That means kernel mode. This part is the part of your user mode. We Now, if you look into the Linux platform also, this Linux platform also goes for a different possible structures. So here also you can see in the top you have user, in the bottom you have different terminal IO drivers. So here you can see the terminal controller, device controller, memory controller. So these are different hardwares we have. So this part, the part of your different hardwares we have. And at this particular point of time, if you are looking into the user to interact, user can possibly interact here with respect to the part of your cells, commands, and further, if you are looking into, I can go for the compilers. So here we can able to interact with the cells, commands, compilers, interpreter, system libraries, and so on. So the user requirement is completed here, and this makes the part of your system kernel which can allow you to go for the next, which can allow you to go for the next. We can possibly say that that definitely helps the systems to work. And this system to work according to a part of your system programs. So IO system, then file system, then scheduling system, everything is available in this particular system model where we can work with the operating systems. Now, if operating system wants to interact with the hardware, they can make use of another layer that can be your device controllers, and device controller will take the help of the driver to connect. So you can see another layer is here. So kernel interface to the hardware, kernel interface to the system calls. So this can be a layering structure of your system in Unix platform. So operating system normally have a structure system, or we can say layer structure system, which can able to give you a better constructed idea that who is going to do what kind of job. So that's why layer structure is better in operating systems to make use of. Finally, come to the conclusion of the introduction part, where we can say the operating system services supposed to be in this case where this operating system services can go for the user interfaces, and can go for program executions, can go for IO operations, can go for file manipulations. So these are different uses which can be given to a user. So user can get what kind of services, and we can possibly go for communications, so process to process communication, system to system communication. So those communications we can find. And finally, the more and more priority one, so detection and corrections, so error detections and further corrections. So here we are giving a interactive operating systems service, which will be very very necessary over non-interactive operating systems. So these are different possible tasks which we are giving in case of your operating system services at any point of time you are working with your users. Similarly, if somebody asks, I can possibly go for if somebody asks, I can possibly go for the part of your services for system. So that is also there. So there are different services for a system we have, and this particular system can possibly say that I would like to go for complete details to keep in my resource allocation. So which resource is allocated, which resource is not allocated, which resource is free, which resource is on use, how to allocate the resource, everything that must be kept by the operating system, so that we can further do the actions. So you can go for on the part of your executions, and these executions will keep track of the resource allocations. Then coming to the accounting, so keep track of how many users you have and how much number of particular computer resources we have. So those accounting systems we can possibly have, and those can possibly go for the part of your systems to keep track of. So resource allocation and accounting both are working together. So accounting will keep track of the used and unused resources. Allocation will do the allocations. Then completely coming to the next. So how user will get the protection and security? User will definitely get the protection and security depending on the requirement, depending on the accessibility, depending on the permission. That means what permission you have, whether you can able to have access to the file or not. If have, then what kind of access you have. So we can possibly have protection and security also, so that the system can keep track of its files. The user can able to be ensure that whatever the data available in the system, that is not accessible by other than any concerned user, and that makes the system more flexible and secure for the user data. So this is what we have as far as the part of your introduction discussion. You can get questions from here. What are the different services a operating system going to provide to user, or what are the different services a operating system is going to provide to users as well as to the system. We can also get this kind of questions. So this is what we have for today's class.
So
This is
attendance.
attendance. Please you write on the chat board. Huh?
Okay, sir.
That will be taken from there. So
I have a question.
yes. Those are already given. No need to give it again. So if you are not given, you can give that.
Sir, can you please let us know what are the possible questions we are hoping to get from this chapter? Like one is
Okay.
different services of operating system, right?
Yes. Different services of operating system. You can get a question how you can differentiate between time sharing system and multi-programming system. You can also get question like what is the difference between network operating system and distributed operating system. Write a short note on real-time system. So somebody can also ask you write a brief note on different type of operating system. So this kind of questions can be asked. Yes, someone,
Thank you,
anything
sir.
you are asking? Yes, thank
Sir, any books are on operating system we should follow, sir?
you. Yes. Yesterday I told already. You can follow the book written by Galvin. You
Girls.
can
Okay.
see that is operating system concepts and red color book. It is a red color book. You can search anywhere in the market. Purchase any edition. Any edition, old edition also
Yesterday we
okay.
have class.
Yes.
Yesterday do we have class on Sunday?
Yes. Yesterday there is a class I had taken. Amun is there and as well as
Okay, okay.
yes, yesterday and
Okay, I
today.
didn't know about that.
Yes.
Okay.
Okay.
मैंने आपको व्हाट्सएप भी किया था श्रेया.
Oh,
मुझे तो नहीं मिला कुछ.
maybe missed.
व्हाट्सएप किया था मैंने 7 o'clock के अराउंड.
ओके देन मैं मुझे लगा कि संडे क्लास नहीं होगा. आई थॉट ऑफ आस्किंग मोहन बट पूछा नहीं मैंने सोचा क्लोज्ड है. ओके.
Okay. Anything need to ask anything from the first module? Any doubt or any clarification you need?
नो सर.
आस्किंग मी.
Yes, Mohan, are you asking anything?
No, sir.
Okay.
No, sir.
Okay. Okay. Then thank you all.
थैंक यू सर.
Thank you, sir.
Okay. Welcome.